Is there another planet that is very near Earth, similar to us, where there could be progress? No doubt. I mean, the nearest star framework to us, Proxima Centauri, really has a decently Earth-like planet around it. We don't have the foggiest idea very much about how Earth-like it is, but it's called Proxima B. The James Webb Space Telescope has uncovered something stunning on Proxima B, indications of tumult and destruction nobody expected. But now, new information shows it's anything but safe, bringing up chilling questions about what's truly happening there. Could this be an impression of our own future, or something even more obscure? Let us reveal the stunning truth about Proxima B that is driving Earth to the verge of absolute breakdown. Lights on Proxima B leave scientists dazed. Proxima B is the nearest exoplanet to Earth, circling the red dwarf star Proxima Centauri, a little more than 4 light-years away. This super-Earth has charmed scientists since its discovery in 2016, fundamentally because it exists in its star's habitable zone. This means conditions could exist that might support liquid water, a key element for life as far as we know. Anyway, late observations from the James Webb Space Telescope have painted a far more complicated and disturbing picture. Before we dive into this, it's clear that what the James Webb Telescope revealed on Proxima B is undeniably more upsetting than anyone could have imagined, and the surprises don't end here. Dissimilar to Earth, Proxima B is tidally locked, meaning one side eternally faces its star, while the other is in timeless darkness. At first, researchers hypothesized that any potential living things, if present, might have developed adaptations to move energy between the day and night sides, maybe using solar panels or artificial lights. It was a thrilling thought until Webb sensors started picking up some startling signs. The possibility of detecting artificial light on distant planets has long been considered a possible method for recognizing technologically advanced human civilizations. Its incredibly sensitive instruments captured faint but surprising light emissions emanating from Proxima B's dark side. These signs bore striking similarities to the kind of artificial light humans produce. While closing this as proof is enticing of alien technology, the truth is far more intricate and maybe more alarming. Researchers analyzed the patterns of the light and found abnormalities that don't align with natural phenomena like volcanic activity or auroras. If these emissions are artificial, it suggests the presence of a civilization that is at least as advanced as our own. Anyway, what kind of society would flourish under such extreme conditions? And more critically, what else could they be capable of? Proxima B's climate is no paradise. The red dwarf star it orbits is known for brutal solar flares, which could strip away a planet's atmosphere over time. These flares bombard the surface with intense radiation, creating a landscape that is harsh and unforgiving. Yet if there's life there, it has likely evolved to survive or even to cope with these conditions. This raises disturbing questions. Might such a civilization someday view Earth as a resource or shelter in comparison to their hostile home? And if they've developed the ability to survive on Proxima B, how advanced could their technology be? Adding to the intrigue, a narrowband radio transmission, resembling the type used in Earth's communication technologies, was detected coming from Proxima B in 2021. This was no ordinary static. It carried a specific frequency that implied its artificial origin. Although further investigation has yet to officially confirm its source, the possibility that it's a message from an intelligent civilization cannot be ruled out. What's especially chilling is that the signal didn't just appear once. Subsequent observations revealed repeating patterns, as if the source was trying to establish contact. Nevertheless, are they reaching out in peace? Or could this be something far more sinister? As researchers dig deeper, the implications of these discoveries grow increasingly ominous. The potential artificial lights on Proxima B's dark side suggest a level of technological advancement that could surpass our own. If these lights are indeed from a human-like civilization, what is their purpose? Are they merely a means of survival, or do they signify something bigger? Humanity's history is riddled with examples of exploration turning into conquest. As we examine Proxima B, we must consider how advanced civilizations may view our own. If we've detected them, it's likely they've seen us too. And given the fragile state of Earth's climate, would they see us as a civilization worth saving or just another obstacle in their path? What we've discovered about Proxima B opens up groundbreaking ideas and warnings, making us wonder how these revelations could change everything we know. The rising stakes in Proxima B's discoveries, as the Webb telescope continues its work, highlight a sobering reality. The search for extraterrestrial life is no longer merely about curiosity, but about preparing for the unknown. Proxima B might not just be a distant, uninhabited planet. It may be a harbinger of what's to come, a glimpse into a future where humanity is no longer alone, but faces challenges far greater than we've ever imagined. The James Webb Space Telescope's work on Proxima B is far from over. Future missions plan to gather much more detailed data, including atmospheric composition and potential biosignatures. These efforts will require exceptional precision and cooperation, as the stakes couldn't be higher. Proxima B's radio transmission detection shows just how far science has come and how much further it still needs to go. The possible outcomes are vast. Space experts continue to fine-tune their methods, using Webb's capabilities to unravel Proxima B's atmosphere. They aim to determine the presence of specific gases like carbon dioxide, methane, and water vapor, the building blocks of life as we understand it. Understanding Proxima B's potential habitability isn't just an academic pursuit. It forces us to reevaluate our position in the universe. Should we eventually confirm the presence of advanced life forms on Proxima B, what would that mean for humanity? Would it unite us, or would it deepen existing divisions? In the meantime, researchers are grappling with the monumental challenges of interpreting data from light years away. With Webb's ability to analyze faint signals, astronomers can distinguish normal phenomena from potential artificial emissions. This meticulous work ensures that any conclusions drawn are based on solid evidence, not speculation. The revelations made by the James Webb Space Telescope about Proxima B are part of something much bigger. Scientists are studying exoplanets like Proxima B not only to search for signs of life, but also to understand how planets form and change over time. For centuries, humans have been fascinated by the possibility of life beyond Earth, but investigating these possibilities also raises deep and difficult questions. How would we approach the unknown? What might it mean for us to find life elsewhere? Proxima B is close enough to Earth to make it a top choice for further research. This planet gives us a rare opportunity to study something that could forever change how we view the universe. Consider the possibility that there are intelligent beings there. How might we try to communicate with them? And perhaps the hardest question of all, should we even try? Just because we can doesn't necessarily mean we should. The James Webb Space Telescope has given us a stunning new way to look at the stars and much more. But with each revelation comes a growing list of questions. Proxima B could be just the beginning of what we uncover in space. As we look deeper into the universe, we may find both answers we've been seeking and challenges we never imagined. Each new discovery is like paving a path for more possibilities, and some of them could completely change how we understand our place in the universe. The lessons we learn from Proxima B will help guide us as we continue to explore what's out there. Science isn't just about finding answers. It's also about knowing which questions to ask. The search for life beyond Earth isn't just about curiosity. It's about expanding our understanding of who we are and where we fit in the universe. This investigation will push us beyond our limits, testing our ideas and shaping the future of humanity. As we continue to move forward into space, Proxima B will remind us of the importance of thoughtful exploration. It's not just about what we find, but also about how those discoveries affect us. What does it mean to find life on another planet? Could it change how we treat our own planet? The search for life among the stars may redefine what it means to be human, and drive us to think in ways we never have before. Space exploration is not just a scientific mission. It's a way to push the boundaries of what we know and what we can imagine. And as we continue to uncover the universe's many wonders, we are not only shaping our future, but also realizing what it means to explore with care and curiosity. Our inquiry didn't end with Proxima B. It has extended over years, showing us planets in a universe that is much more complicated than we first thought. The golden age of exploring planets in our solar system is undoubtedly awe-inspiring. For millennia, we've gazed at the stars, wondering what's out there. But it wasn't until the last couple of centuries that we began to unravel the bigger picture. Once the 1950s hit, it was all about mechanical spacecraft becoming our way to expand human curiosity beyond Earth, kicking off a new era of discovery. Back in the late 1950s, the U.S. and the Soviet Union association were secured a wild contest to investigate space. The two countries pointed their sights at the moon. The U.S. had a harsh beginning. Its initial Trailblazer missions confronted hiccups with 4 bombed endeavors in succession. However, they didn't call it quits. By 1959, Trailblazer 4 got through, getting away from Earth's gravity and gathering information as it passed by the moon. In the meantime, the Soviet Association's Luna missions were causing disturbances. Luna 1 dashed past the moon, Luna 2 crashed into its surface, and Luna 3 sent back the very first pictures of the moon's far side, giving humanity another viewpoint. Then came the 1960s, and space exploration hit another level. In 1962, NASA's Sailor 2 impacted the world forever by effectively flying by Venus, uncovering basic insights about its air. 3 years after that, Sailor 4 took the spotlight with the first flyby of Mars, snapping photographs that showed a cratered, rough surface. This stirred up prior thoughts of a rich, Earth-like Mars. It wasn't simply a red spot overhead anymore. It was an entrancing world asking for more investigation. The 1970s and 1980s ended up being brilliant years for space exploration. NASA's Viking program landed 2 shuttles on Mars in 1976, looking for life and studying the world's geography and atmosphere. While no indications of life were found, the information gathered was hefty. The Soviet Association didn't hold back either. Their Venera missions to Venus achieved some mind-boggling successes. In 1970, Venera 7 became the first shuttle to land on another planet and send information back, even under Venus' extreme heat and crushing pressure. Later missions painted a distinctive image of Venus' terrible landscape, complete with liquid stone and sulfuric acid clouds. If the Viking and Venera missions were noteworthy, the Voyager program was absolutely epic. Launched in 1977, Voyager 1 and Voyager 2 reworked the book on the outer planets. Voyager 1 captured staggering details of Jupiter and Saturn, including their moons and ring systems. Voyager 2 went significantly further, visiting Uranus and Neptune, the first space probe to ever do so. En route, they found 48 moons, active volcanoes on Jupiter's moon Io, and brand new planetary rings. Even after their primary missions finished, the Voyagers continued on, sending information from the edge of the solar system. By the 1990s and early 2000s, space exploration was going all out. The Galileo spacecraft, launched in 1989, gave us a closer look at Jupiter and its entrancing moons. Europa, with its icy surface and possible underground sea, became a prime candidate for future missions looking for life. Then came the Cassini-Huygens mission, a collaboration between NASA and the European Space Agency, reaching Saturn in 2004. Cassini revealed the planet's stunning rings and peculiar moons. Its Huygens probe even landed on Titan, Saturn's largest moon, revealing pools of liquid methane in a thick, orange-hued atmosphere. Asteroids and comets soon joined the list of targets. Japan's Hayabusa mission successfully brought back samples from asteroids, giving a window into the origin of the solar system. The European Space Agency's Rosetta mission took things further, orbiting and landing a probe on a comet. Imagine chasing a speeding ice rock through space and actually landing on it. The data gathered from Comet 67P/Churyumov. Gerasimenko was like looking into an incredible time capsule. Space exploration isn't just an American story. Different countries have made staggering contributions too. China's Chang'e program has pulled off successful lunar landings and even returned samples from the moon. India's Mars orbiter mission, fondly called Mangalyaan, delivered key insights about Mars' atmosphere, all on a budget that would make Hollywood envious. Europe's missions, like Rosetta and Mars Express, have added layers of understanding to our grandiose map. What's next? The focus is moving to icy moons and sample returns. Jupiter's moon Europa, with its hidden ocean, is a hot target for missions like NASA's forthcoming Europa Clipper. Mars is set to send its first rock samples back to Earth, potentially opening clues to its ancient past. And beyond that, who knows? With advancing technology, there's no telling how far we'll go or what we'll find. One thing's for sure, the exploration of our solar system is just getting started. Even with all we've found in space, the biggest questions about the universe still leave us searching for answers to things we don't yet understand. The universe is a vast, chaotic place, and there's no denying that it's filled with unanswered questions. Take dark matter, for example. It's like the invisible glue holding galaxies together, but no one knows what it's really made of. Scientists have tossed around ideas like WIMPs or axions, but they have nothing solid. It's almost frustrating how much we know it's there without understanding what it truly is. Then there's dark energy, which is a completely separate headache. This stuff makes up most of the universe and seems to be pushing it apart faster and faster. How does that even work? We call it energy, but really, that's just slapping a label on something we barely understand. It's a cosmic shrug, and scientists are left scratching their heads over it. And the Big Bang, sure, we have a basic sketch. Everything burst out of a small, hot, dense spot. But what struck the match? What came before all this? And where's everything headed? Eternal expansion? A big crunch? Or something in between? It's like reading the first and middle parts of a book with practically no idea how it starts or ends. Galaxies themselves are a mess of unanswered questions. We have the basics down. Clouds of gas collapse, stars are born, black holes form, but the details are maddeningly unclear. Why do some galaxies seem to spin while others are just blobs? And what's the deal with the supermassive black holes sitting at the center of nearly every galaxy? Are they puppeteers pulling the strings of galaxy evolution, or just side effects of the massive chaos? Speaking of black holes, they're like nature's ultimate puzzle. You throw something into one and it's gone poof, at least from our perspective. But where does that matter go? Does it jump out elsewhere? And the singularity, the place where everything gets crushed, what even is that? Physics just breaks down by then, leaving us with wild theories and no answers. Life beyond Earth? Don't even get started. We've been searching, listening, and speculating for decades, yet no hard proof. If life is out there, why haven't we seen it yet? Are we the lucky ones? Or are we just looking in the wrong places? It's like searching for a needle in a cosmic haystack without even knowing if the needle exists. Reality is no less confusing. Is time travel possible? Are there other dimensions we can't see? We live inside space-time, but we barely understand it. It's like trying to explain the ocean while standing in a puddle. Ordinary matter is supposed to be the stuff we know best. But even there, we're missing parts. There's a chunk of the universe's matter that's just not showing up. We call it dark matter, but it's just more stuff we can't find. Neutrinos, tiny particles that barely interact with anything, are another scientific migraine. They're everywhere, but figuring out their exact mass and role in the universe is like trying to solve a puzzle with some of the pieces missing. The process of star formation is another area where we're left guessing. We know stars are born from collapsing clouds of gas, but why do some stars end up huge, while others are small? And why does the same process seem to apply everywhere in the universe? Cosmic inflation is widely accepted, but what caused it? Imagine the universe expanding faster than the speed of light in its first fraction of a second. What drove that burst? And what made it stop? It's like stepping on the gas of a car and then slamming the brakes, without any clear reason for either action. High-energy particles speeding through space are another inexplicable mystery. Where do they come from, and how do they get so much energy? These particles could help us unlock secrets about the universe. But for now, they're just adding to the pile of questions. Gamma-ray bursts are like cosmic fireworks on steroids, but we don't know what's setting them off. Are they the death throes of massive stars, or something even more mysterious? The energy they release is incredible, and figuring them out is like trying to decode a massive Morse code. Interstellar dust and gas might seem boring, but they're crucial for star formation. Where does it all come from, and how does it behave? It's like trying to follow the steps of a recipe across a chaotic kitchen. Exoplanets, planets outside our solar system, are another tantalizing mystery. How do they form? What are they made of? The universe is full of questions, and with every discovery, new ones arise. The journey is far from over. Outside our planetary group, the universe is ending up ridiculously assorted. Some are burning hot, some are frozen, and a couple could even be livable. Yet how would they structure, and what makes them so different from each other? It's a monster speculating game. The thought of multiverses, different universes existing close by our own, is tempting and baffling. If they're real, how might we ever prove it? It's like difficult to see outside a box when you're stuck inside. The chase for a theory of everything, one thought that integrates all of physics, wants to pursue an illusion. General relativity and quantum mechanics don't play nicely together, and seeing as a unifying theory may be the hardest challenge science has ever faced. Gravitational waves and space-time have given us a better way to notice the universe, but we're just starting to expose what's underneath. What other sources of these waves could exist, and what might they tell us about the universe? Neutron stars, leftovers of monstrous stars, are outrageous all around. They're thick, odd, and nearly impossible to study. Concentrating on them pushes how we might interpret matter and physics to the edge. The big-scale design of the universe, with galaxies clustering into groups and voids extending between them, raises huge questions. What shape does this vast web have, and what does it tell us about the forces at play in the early universe? Planetary systems, including our own, still hold a lot of questions. How do they structure, and why are they so different from each other? Even the rings around planets like Saturn are still baffling. Magnetic fields are everywhere in space, but their role is often unclear. How do they impact star development or system dynamics? We know they're significant, but the details are cloudy. Fast radio bursts, quick flashes of radio energy from distant sources, are among the most current cosmic mysteries. What's causing them, and why are they so brief? The question is still totally open. The cosmic microwave background, the faint glow left over from the Big Bang, is like a baby image of the universe, but deciphering every detail of it is a challenge that keeps researchers busy. Is Proxima B a warning for Earth's future, or could it hold answers we're not ready to confront? Share your thoughts, and make sure to like and subscribe for more.